All right, so for today, I'm going to teach you increasing and decreasing. Imagine for a moment that we just stayed in the first quadrant and we made a graph that started going up and then it went down for a little bit and then it went back up again. Would you please make that on your graph? How high up and down it goes is not that critical. It just has to be going up, come back down, and go back up. I rode in a hot air balloon one time, and in the hot air balloon, it was really cool, by the way. If you get a chance to do it, it's awesome. It's like nothing you've ever done because it goes with the wind. If there is any wind, you move at the speed of the wind. And so you have this awesome feeling of it. It's just super quiet because you're going exactly at the speed of the wind. And you're seeing the landscape move underneath you, and it's silent, and there's no wind, and it was super cool. The only thing that'd be more cool is if I got to jump out of it with a pack on my back and do the whole skydiving thing. I've done skydiving too, but I've never done the combo. That would be an awesome combo. The skydiving I did with the guy on my back, the tandem deal. That was really cool. By the way, if you're thinking, I want to do that, wait till your 16th birthday, because that's the earliest you can do it, is age 16. All right, so anyway, this thing went up and it went back down again. At some point, the height decreased. Would you agree that you see an area where the height decreased? All right, that's called a decreasing interval. Make it a different color, please. Draw over it in a different color where it was decreasing. Now we need to know where it was decreasing, and the way we describe these intervals is we only use x values. In terms of x, would you agree that when you go way, way, way to the left, you got negative infinity over here? And when you go way, way, way to the right, you get positive infinity over there. Are you with me on that? I'd write them in. It won't take long. Now, my question is, if I tell you that this point right here was at, let's say it's 3 hours into the trip, and let's say it's in thousands of feet. You went from 4,000 feet, 3,4. Do you get that's at 3 hours, the height of the balloon maxed out at 4,000 feet, but you just put a 4 because it's in thousands? See how the 3,4 could work? And then this spot is lower, obviously, right? And it's more time. By the 5th hour in the flight, you had lowered to, let's say, 3,000 feet, 5,3. Do those points make sense to you so far? Then the way you would say the time period, time is the x, it's always the x, times the independent variable, times down here. Okay, the time that it was decreasing, would you please put parentheses and a comma and see if you can answer the question? If you have to use parentheses and a comma, take a guess what it is, and I want you to compare your answer with the kid sitting next to you.
Only 2 hours it equals.
For today, I want you to compare with the kid behind you. For today, I want you to compare with me. For today, I want you to compare with the other kid. For today, I want you to compare with the
Was about to do that. All right, so I know I didn't give you much, and I never even told you how to do it, but did some of you figure out that it was from 3 to 5? Raise your hand if you got that right. All right, I got a few of you. Now that you know it's from 3 to 5, let's talk about it. From hour 3 to hour 5, the height was decreasing. Do you get that the x values here are the times? So since I told you I wanted the times, the only numbers you could have picked were the 3 and the 5. All right. Now, if this was a real life situation, everybody died. Why? It's too fast.
It's not about the speed. That's a valid question. Was it going up or down too fast to survive? Look at that arrow at the end. Did it ever come down? So the balloon just kept going up forever. Okay? Eventually, that ends badly. Either you don't have enough oxygen or you freeze to death. As it gets really cold up there, it's 40 below. Even with a jacket, you're not going to last long. Okay, so how would I write the increasing interval for this? This part right here, that gets its own interval for the increasing time period. Well, I'm guessing it's parentheses and a comma again. Use logic and what we just talked about and tell me where it was increasing. Only 3 people had it last time. Compare now with the kid next to you and see what you think. It's okay to be guessing. I haven't told you how to do it yet. All right, so here's the clues that could have told you what the answer was. I told you to only use x's. So we had to use the 5. And then if you were like, well, when does it stop increasing? I said it never stopped increasing. So what do you think the answer is? 5 to infinity. Raise your hand if you had that one right. Okay, now we're up to almost everybody. Cool. Now, is there another interval of time where the height was increasing? Yes, there is. So right underneath that, put another interval where it was increasing. I think he's talking about this part of the graph. So I think there must be a 3 in it because he said only to use the x numbers. And then I'm just trying to decide whether or not I should say that time goes to negative infinity since it's time. That doesn't feel right to me. So in the context of this question, a really smart kid would have probably said from 0 to 3. But I would totally forgive you for saying negative infinity to 3. In fact, on the test, usually we don't have any context, which means since this is an arrow going down, you would have been right to say negative infinity, but even righter to say 0 because in the context of time, you can't go negative time. Okay, so here's a nice simple question to see if you've got increasing and decreasing intervals. Do not copy the picture. Only answer the question about the picture. Don't copy the picture. It'll take you too long. That spot is negative 1 comma 4 right there. That spot is 6 comma 0. I want to know the decreasing interval. There is no context. There's no balloon. There's no story about height. It's just a graph. Can you tell me the decreasing interval? The decreasing interval. If you have a short-term memory, you remember this is only about x's, and so you should have used only those 2 numbers. And if it's between here and here, it would be between negative 1 and 6. Raise your hand if you had that one right. Awesome. Would you agree that there were intervals that were increasing on this graph? Yes. And a lot of kids get confused by this down arrow because somebody will tell them that it's increasing here and they're like, but there's a down arrow. No, no. You read from left to right. So in that red zone I just painted there, that's increasing. You read from left to right, so that is increasing in there. Would you please write the correct interval for describing that? It's increasing. I put a little I and C over it. It's not actually required. Say G. What do you say? Negative infinity lives over here. You are correct. Negative infinity until it stops increasing at negative 1. It's very tempting to use the 4. I keep pounding on these are only x intervals. These are intervals about x. All right? And then there's one more interval, and I'm going to show you the proper way, because you're in honors, to put two increasing intervals next to each other. You'd put them like this, and the other increasing interval is 6 to infinity. I'm right, INF, just because sometimes we do Schoology quizzes, and you don't have an infinity symbol. And does anybody, for extra respect points, know what I just did wrong about putting these two intervals next to each other? It's a very picky thing. You, very good. I heard that from a couple smart kids. I know you're all smart, but U stands for union. That's like saying this or this. They're both, and or sounds like I'm saying one or the other, but or is actually the right word for that symbol. That's the or symbol. It's also the union symbol. That's what you should have had in there. All right, good. And on the test, I don't know. Honestly, it's picky, but I don't know if we're going to mark it wrong for that. Just like last time, you were supposed to say 4 plus 3i. Some of the teachers didn't mark it wrong if you said 3i plus 4. Okay, and so therefore I couldn't mark it wrong either. So I wanted to tell you it had to be that way in case we were going to be really picky. Well, in case we're really picky, you have to have a U in there. But I don't know, on the test, if you had everything right, maybe we'll decide to let kids by with not having the U, but try to remember the U. Okay, good enough on that. That's called increasing and decreasing intervals. This next part, do not copy this. Just listen. I'm not caring about my increasing and decreasing intervals right now. What I care about is that's a low spot in the graph, and there's an official name for that. Now I want to ask you this. Is that the lowest spot that the function ever goes? No. But it is a low spot. Using the word maximum or minimum, which do you think this will be? A minimum. There's two kinds of minimums though. There's an absolute minimum or a local minimum. What's your guess? That's called a local minimum. All right, now don't take notes on this. You can take notes on the next one. This is a local min. Now, the next common thing for kids to say, so what's the absolute min then? There isn't one. I know it's tempting to say negative infinity, but that's implying that negative infinity is a low spot. There is no absolute lowest spot. So the absolute minimum, there isn't one. You just say there is no minimum. There's a local minimum, but there isn't any absolute minimum. All right, now I purposely made this so I tried to keep them equal height. Okay, but in the reality is that one looks a little higher to me than that one. So I'm going to actually say that the one spot is a little higher. The reason is because I want to have an absolute maximum for this graph. Do you get this? If this is a little bit higher than this one is, then this would be the absolute max. And this would not be an absolute max. It would be a what? Local. I heard somebody whisper it. Max. The local max. All right. Do you get that in this room, there is a kid who would win if we had an arm wrestling contest? There'd be one kid who would be the strongest in the room. That would be like the local max. Does that make that kid automatically the absolute max of the world? Yes. Probably not. Outside this room, there's probably some kid that's stronger than all of you guys. All right, so then that means that you could have a local max, strongest kid in the room, as opposed to the absolute max. There is probably somewhere, it'd be really hard to judge it, the strongest kid in the world. All right. I don't know if they ever even try to do something like that. All right. So this one I want you to actually take notes on. Make a graph that has two peaks and a valley. This is going to be at 3, 4. This is going to be at 9, 8. And over to the right, I want you to list local min, local max, absolute min, absolute max. Sometimes the answer is none. Sometimes the answer is a point, and what do I need to tell you before you can finish this question? There's something you'd have to know. Yeah, that low point. That low point there, we will say it is at 5, 2. You could not have finished the question unless I told you that. All right, now you got enough. At the end, after we're done with these, I'm going to ask you for where was it decreasing. But finish the other questions first. You have a kid next to you. You know who I usually pair you with. After you've done the local min and the local max, would you please compare with them and see if you're on the same page? There's a technicality that's going to get some of you. So here's your answers. The local minimum was 5, 2. The local maximum was 2 things. Very common for people to forget that the absolute max is also a local max. 3, 4. Now these are not intervals, they are points. So I'm not going to put a U next to it. Don't try to burn me with that, because it's only on intervals, not when you're listing points. 3, 4. 9, 8. I could put a comma between them, don't have to. All right, absolute minimum, the lowest of them all. There is no absolute minimum, or none. And the absolute maximum, the highest of them all, 9, 8. The decreasing interval, there was not just one this time. I'm sure you caught the decreasing interval of between here and here. It was going down, and there's the x values only, so 3 to 5 was an easy one. But did you also notice that it was decreasing there? There's 2 intervals where it's decreasing. I made them blue. From 3 to 5 and from 9 to infinity, and this one needs a U in between it. Now, some kids are like, but it's going down. That should be negative infinity. These are only x values. When you go far enough this way, you get positive infinity. That's not... the y value would be negative infinity, but these aren't y values. They're only x values. All right, cool. You've learned everything. That's it for today. Yay. Now let's open up the Schoology quiz. Find it. Open it. Changing it to 2 times by average score, because that's what I always do. 2 tries, you get the average of the scores. You get the answers after the first try. Okay, question number 1. It's got a hideous looking graph, and then it says, what's the absolute minimum? No, maximum. Below. Well, that's just a point. So your answer has to be written as a point. Oh, cool. Okay, good. So hopefully you can pick out the one that is the absolute max. Good question. Relative max is the same as a local max. Relative
is relative to the points near it. It's kind of like local. So relative and local, you can connect those two words in your head. All right, I hope this feels like a super easy day. And now, I totally hope you get stuck and ask me a question. It makes me feel like I'm doing my job.